Hello and welcome to the third video on this D1 chapter Algorithms on Graphs. On the screen, Prim's algorithm for the same exam question we had in the previous video. I'm going to start with A. I like to start with A because often the exam question will tell you to start with A. From A, the best choice is A to C. I'll sketch the graph as we go. From here, we need the shortest arc that will add another vertex into the tree. So we've got 24, but better to do 21. 23, 25, 29, so 21 is the best option from here. From there, 11 is obviously the best option, although there is a 12. I almost missed that. There is a 12 across the top. 11 still the best option. Then 12 is the best option. From here, 14 is the smallest number, but that would cycle. So 15 is the one to choose. Coming down here to G. From here, 18 would cycle. 20 is looking good. No, 17 is better. And I've done it again. I have not put the order in. Oh, well, here's a good example of what not to do because it's going to be difficult for me to remember. We did AC for 9, then BC for 21, and then it must have been BE before BF because they're coming from the same vertex and BE was smaller. Then we did FG, FH. Again, from the same vertex, the smaller one must have come first. So we're looking now at getting J or D into the graph, and the best way to do that is the 20 along here. So I'll do E to J for 20. And finally, down to D, the best option to get to D is the 25 from C. CD. And that should be the same graph as we had in the previous video. In this video, we're going to apply prims, but we're going to apply it on a distance matrix, which is in essence the same algorithm as we had before, but how it looks on paper is different because we're applying it on a distance matrix, so you can't see quite the same information, or I should say you can see the same information, but not in the same way. Here it is in its distance matrix form. You start with any vertex, as before, then you delete the vertex's row in the table and number its column. What you're doing there is making sure that no other vertex later gets you back to one you've already got in your tree. Then you circle the lowest undeleted entry in the numbered columns, so you're only using columns from vertices in your tree and extending it to a new one. That's the next arc and therefore the next vertex to join the tree, so keep a note of that. Repeat until all the rows are deleted, i.e. all the vertices are in the tree, and finally list the arcs in the order they were added as before. So here's a little one on the side while the algorithm is on the screen. Start with any vertex, A, again, easy one to start with. You delete that row and number its column. So A is column 1 and A's row is gone. Now we find the lowest undeleted entry in the numbered columns. So I only have one numbered column, so I'm only looking in column A. The lowest undeleted entry is this 3 here. Circle that. That's part of the process that the examiner is expecting to see. And if you remember your distance matrices, this is the arc AB. So AB is the first one in my tree. Now I've got B in the tree, so we delete B's row and we number B's column. The next one in, so this is the second one, put a 2 on top of that. And again, this is what the examiner is expecting to see. Then you go down both A and B. Remember, it doesn't matter which one we extend from, so long as it's from one that is in the tree. So the smallest number in these two columns is this 5 here. So I circle that, and that's going from A to C. That's the second one that goes into my tree. I delete C's row, and I number C's column. Now I'm looking in any of these 3 columns for the smallest undeleted number. That's the 6 here. Circle that, and that is BD. Delete that, put a 4 on there, and I finished. It was a small graph, only 4 vertices, so 3 arcs are enough to get a minimum spanning tree. That's the idea. Let's do it on a slightly bigger example. So using Prim's algorithm on a distance matrix, find the minimum spanning tree, start at A. An exam question will sometimes tell you where to start. List the order of your arcs and state the weight of your tree. So starting at A means we need to delete A first, put a 1 on top. The smallest undeleted number in this column is the 4, and that goes from A to E. So that's the first arc. That means E is the second vertex in my tree, and I don't want to come back to E later, so I delete that column. Now from A and E's column, the smallest undeleted number is not here, it's too big, it's this one here, the 5. So I'm going now from A to D, connecting D into the tree, the third vertex, and I don't want to come back to D, so we delete that. Now out of these 3 columns, the smallest undeleted number is the 3 here. So D can connect to C, and that brings C in, the 4th vertex into the tree. DC is the one that I've got. Now the 4, this is to connect B into the tree. The best way to do that is to go from D for this 5 here. That brings DB as the final arc. B is now the 5th vertex in the tree. These are my arcs. AE was a 4, AD a 5, DC was a 3, and DB was a 5, that's 17. As with many of these algorithms, it's not too difficult once you get into it, but you must have enough practice to be able to recall these without seeing the algorithm written down in the exam. You will need to remember these processes. So have a good lot of practice at that from the questions in exercise 3C, and maybe I'll see you for the nearest neighbor algorithm in the next video.